Hi there! Today we're going to take a look on the glue constraint. So we already have one quick setup here for the simulation, just a box, some Voronoi fraction, and if you run the simulation, here you go, you break it in pieces. So we're going to see how we can add a glue constraint between the pieces so they try to hold together. What you see here while it's falling is not that the pieces are holding together to the impact, but it's just falling together. And inside our dock network, also is easy setup is just our RDB pack geometry and the ground plane for collision. So the first thing we have to do is create a piece of primitive, connect each one of the points. So that's going to be the liaison, the link between them. And the way to do it, since this is a pack geometry, so it's stored in the centroid of each one of those pieces. So if you go here and drop connect adjacent pieces, and you can see this warning little thing. Let's see what's going on here. It says an attribute name, it's not recognized, and that's happening because on the assemble node we're not passing or transferring the name created by the Voronoi. So you just add name, and now that attribute automatically you're going to be passed through here this information. And here with the connect adjacent pieces, you have a search radius. So you see as you increase it, you start looking for the different points and connect them. And you also can increase the amount of points that you'll be looking for. So you can see you can have a kind of a network, connect all the points together, and those are just simple primitive connecting there, nothing fancy. But now we can add to each one of those primitives, because if you go to the spreadsheet you can see them on an attribute that you're going to tell what kind of constraint that's going to be. So we can put in an attribute create. That's also going to be done with a wrangle attribute, whatever you feel on the day. That's Houdini many ways. And so let's start to create the first attribute. It's going to be the constraint name, and that's going to be by primitive, and it's going to be a string attribute. So we put the name, it's going to be a glue. So that's what we want to use, is like a glue constraint. And we can add an attribute, the same, you'll be constraint, and now it's going to be type. And this type is just say what kind of a constraint is going to be. We're going to be a transformation constraint with the position, a rotation, and in this case we want some that holds all, rotation and a scale, and translation. So again, as a string value, and we just add here all, and that's important, be running through primitives. So now we see we have a glue, and I have a all constraint type for that. And we can just put this inside of a DOP here, so that dive in and have your constraint network there. So as soon as you connect, it's erroring you out because it wants to get some information. So the first is the path, where it's going to be getting the constraint, and you can see just the first, the second contest geometry, and you can put now the glue constraint relationship. If you connect it here, and now you add our attribute that we create called glue. So it's all happy now. And if you go back, so let's just adjust that. If you put a value of -1, it's going to be unbreakable. So it's good to test if it's working. Let me zoom out a little bit. and I'd run it and see now it is working. It's unbreakable. It's like nothing has happened, and you can start adjusting the strength of it. See, some pieces trying to hold it together when the other breaks. So that's the simple setup for the glue constraint, and thanks for watching, and see you next time.